All right, welcome back to part 2 of the Math 2 Semester 1 review. It says to write an expression, number 10, write an expression that is equivalent to square root 7 times square root 7 plus 3 square root 8. All right, so just like when we multiply, for example, if we had x times 2x plus 3y, we would multiply x times x, we would multiply x times y, we would multiply coefficient to coefficient, coefficient to coefficient, and we would get 1 times 2 is 2, x times x is x squared, plus 1 times 3 is 3, x times y is xy. So we're going to do the same thing here. We're going to distribute through, and we're going to multiply coefficient to coefficient. 1 times 1 is 1. And then root 7 times root 7 is root 49, plus 1 times 3 is 3. Root 7 times root 8 is, now I'm just going to leave it as 7 times 8. Remember, in just a second, I have to break this down anyway. The square root of 49 is a perfect square. Square root of 49 is 7. I don't know why people keep doing this. The square root of 49 is the square root of 7. That is not true. Quit doing it. I want you to look on your calculator. The square root of 49 is 7, not square root 7. The square root of 7, the square root of 7 is not 7. It's 2.645, whatever. So quit saying that the square root of 49 is equal to the square root of 7. All right, plus 3. 7 is a prime. 8 is not a perfect square, but there's a factor in it that's perfect. 4. 4 times 2 is 8, and then times 7. The square root of 4 is 2. It's going to come out. It's going to multiply, remember, multiply with 3. And then under the radical, we have a 2 and a 7. So we're going to simplify. We have 7 plus, this is 6, square root 14. And then if you want to check, you can use your calculator to check that you've done the work right. On the calculator, you can do square root of 7. And then on my calculator, you would have to hit 7 square root and then hit times and put some parentheses. So square root 7 and then plus 3 square root 8. Whoops, delete that guy. And this is 29.449. If I check 7 plus 6 square root 14, I get the same answer. So you can always check radicals. You do need to know how the calculator works though. All right. Let's go ahead and flip over. We're on number 11. It says the area of a the area of a square is 48 a to the 5th b to the 8th inches squared. What is the length of one side of the square in simplest form? Okay, and it says recall the area of a square can be found using area equals side squared. They're giving you that for a reason. So the area equals the side squared. And we also know the area equals 48 a to the 5th b to the 8th inches squared. So what we're going to do is we're going to plug this in for a. Remember, we don't want to plug it in for s squared. We already have it equal to, right? We already have done that. We want to use s in our formula so we can get s. So we have 48 a to the 5th b to the 8th inches squared equals the side squared. Now I don't want a side squared though, I want one side. So to get rid of the square, I would square root both sides. And I get that the side equals, the square root of 48 is not a perfect square. It is 4 times 4 times 3, and then a to the 5th, b to the 8th, remember this is all under my radical, 1, 2, 3, 4, 5, 6, 7, 8. And then I even have inches times inches, right? And the square root of inches squared is inches. All right, so any perfect squares or pairs are going to come out. So the 4 is going to come out, an A is going to come out, another A will come out, a B will come out, a B will come out, a B will come out, and a B will come out. Under the radical, I'll have 3A, and don't forget this is inches, equals the side. And then I can rewrite this A to the first, A to the 1 plus 1 is 2, so 4A squared, B to the 1, 2, 3, 4, B to the 4th, square root 3A inches is the side length. Now, I know a lot of you guys don't need to do this whole thing right here, but so many of you are still messing up square roots. Stop messing them up. Just expand it out and take out pairs. Most of us, though, can see that 16 times 3, which is the square root of 16, is 4. And then A to the 5th, I can take out 2 pairs with 1 left over. And then B to the 8th, I can take out 4 pairs with none left over. All right, number 12, it says an equilateral triangle has a height of 15 inches. What is the exact length of one of the sides of the triangle? So number 12, my equilateral triangle has a height of 15. Now, when we have a height, it's also called an altitude. Altitudes make a 90-degree to the base. And in an isosceles or equilateral triangle, when you drop an altitude from the vertex angle, it cuts the base into 2 congruent segments. So these are congruent pieces. And then finally, this angle was a 60. It also cuts these angles into 2 congruent angles, which are 30 and 30. So this is a special right triangle. It's a 30, 60, 90. You cannot use trig because it says exact length. So exact length means that you have to leave a radical in your answer. So we need to use the special reference triangle for a 30, 60, 90 triangle. So here's my 60 and here's my 30. All right, what I know is that this piece is half as big as this piece. So this is 1 and 2. And then if you use the Pythagorean theorem, you can find the third side, but it's going to be square root 3. And again, I remember there are 1, 2, 3 angles, so the 3 goes under the radical. I know that this is the right ratio because this is the smallest angle. 1 is the smallest side length. 1 is less than. Here's the medium angle, 60. Square root 3 is 1 point something, which is less than. Here's the largest angle, which across from it should be the largest number 2. All right, so please make sure you know your 30, 60, 90 reference triangle. Now we're looking for the side length. You can either find this side or this side, or you can find this one, but then you'll have to double it to get the whole side length. And the most common error last year was students finding this piece and thinking that's what they were talking about. They were talking about the side of the equilateral triangle. So we're going to create a ratio. 15 is to x. 15 is to x as square root 3 is to 2. Square root 3 is to 2. Now you can either multiply both sides by x. Those will cancel. Right. And then divide by the reciprocal, or I wouldn't do it that way. I would, rather than doing that, I would do cross multiplication. So we're going to cross multiply. 15 times 2 is 30. That equals x times square root of 3. And then I would divide both sides by square root 3. I get x equals 30 divided by the square root of 3. Now I do have to rationalize. This goes back to the previous problem on the previous video, number 9. To rationalize, remember we always multiply the top and bottom by whatever's in this radical, which is a root 3. And so we get 30 root 3 over the square root of 9. The square root of 9 is 3, so this is 30 root 3 over 3. And then we can simplify. 3 goes into itself once. 3 goes into 30 10 times. So we get this is 10 square root 3. All right, number 12 says, what is the side length of a square that has a diagonal of 12? So here is my diagonal. Remember, I have right angles in all the corners. And if I take a square and I I draw the diagonal, I'm gonna get 45-degree angles. It cuts these in half, right? It bisects each angle. So those are 45s. So this is a special right triangle. It's a special right triangle, the 45, 45, 90. Again, these have to be equal. So I keep seeing people putting like a square root 2 and then a 1. Those aren't the same number. The same number has to go on both legs, which is 1 and 1. And on the hypotenuse, we have square root 2. Now you can use the Pythagorean theorem, or you can use the same idea that I said for 30, 60, 90s. If you remember for 30, 60, 90, I just said there's 3 different angles. So under the radical goes a 3. Here there's 2 different angles, so under the radical goes a 2. Also, if you notice, on both 30, 60 and 45, 45, 90s, there's some form of a 2 on the hypotenuse. There's some form of a 2 on the hypotenuse. All right, so it says it has a diagonal length. So this length is 12. And we're going to create a proportion to find the side length. You can either find this side or this side. All of the sides are equal. It doesn't matter which one. So x is to 12 as 1 is to root 2. Excuse me, sorry. All right, so I'm going to go ahead and, if you want to cross multiply, you can. In the previous problem, do you see that cross multiplying was easier? In this problem, because of the way I've set it up, I would rather just multiply both sides by 12. However, you can cross multiply and then divide by square root 2. That will cancel out. I get x equals 12 over square root 2. And then again, I have to rationalize the denominator, which would give me x equals 12 root 2 over the square root of 4, which is 12 root 2 over 2. The 2 will cancel. 2 goes into itself once. It goes in there 6 times. This is 6 square root 2. Now, on this one, though, it says round to the nearest hundredths. So at any point, we could have, instead of rationalizing, we could have just divided 12 by square root 2. 12 divided by square root 2 is 8.48. Or at the end, we can do it, right? 6 times square root 2, you get the same answer, 8.48. It does say round to the nearest hundredths, so it's actually going to be 8.45. The 5 will make this 8 round up to a 9, so this will be 8.49 yards. Oh, and the previous one was inches, by the way. All right, in triangle DEF, it says angle, if DF is 12 millimeters and angle D is 40, what is DE to the nearest millimeter? So we're going to go ahead and draw that picture. Number 14. This is E, F, and D, and it says angle D is 40 degrees. It also says that DF is 12 millimeters, and we want to know what is DE. DE is right here on the hypotenuse. All right, so when we have an unknown side length and we're looking for in a right triangle, we can try the Pythagorean theorem. However, in this case, right, we're missing this side as well, so we cannot use Pythag. We can also look and see if we can use a special right triangle, like a reference triangle. This is not a 45, 45, 90. It's a 40, 60, 90. I'm sorry, a 40, 50, 90. It's also not a 30, 60, 90, right? It's a 40, 50, 90. So we can't use no special right triangles. So that leaves us with trig. All right, the 3 trig functions are sine, cosine, and tangent. Now, whoops, not TOA, my bad, TOA. I'm going to do that in a darker color, TOA. Right, so SOHCAHTOA helps us to remember those three trig ratios. Sine is opposite to hypotenuse, cosine is adjacent to hypotenuse, and tangent is opposite to adjacent. So I am using the hypotenuse of the triangle, right? The hypotenuse is across from the right angle, so I can't use tangent. I can actually use either sine or cosine. If I use the 40-degree angle, I would want to pick one of them. If I use this 60-degree angle, I'd want to pick the other one. And the way you can tell is if I'm standing here at this angle, I know I have the hypotenuse and I have to decide if this is my adjacent or if this is my opposite. So adjacent means touching angle D, and this is touching angle D. So this is adjacent. And of course, this is our hypotenuse. And so I will use cosine. So cosine of my angle equals adjacent to hypotenuse. I know a lot of people keep skipping this step. Quit skipping writing the equation. Specifically, not necessarily this step, the next step, which is cosine of my angle is 40 degrees, equals adjacent, my adjacent side is 12, over the hypotenuse is my unknown. I also am going to encourage you to not use the calculator for sine, cosine, and tangent. Instead, I would prefer you use your trig table. So this is asking me for cosine of 40 degrees. So I'm going to go to 40 degrees, which is right here, and then I'll go over to cosine. It's 0.7660. So now I'm going to replace cosine 40 with 0.7660 equals 12 over x. Now, I need to get x equals something. So that means that x cannot be in the denominator. So to get it out of the denominator, I'm going to multiply both sides by x. And then these will cancel. So I get 0.7660x equals 12. And then again, to get x by itself, now instead of now 0.766 is multiplying x, so we will divide by 0.766. And that you can use the calculator for. So 12 divided by 0.766 is 15.66579. So we're going to go back and see, where does it say to round to? It says to the nearest whole millimeter, right? To the nearest millimeter means to the nearest whole millimeter, which would be 16, right? This would round up to 16 millimeters. All right, so the last thing I want you to remember about this problem, a lot of you are just doing this one step. You're doing 12 divided by cosine of 40. There's nothing wrong with that. You get the same answer, right? It's going to still round to 16, so there's nothing wrong with that. The problem is that you don't know when to use that method and when to use other methods. So please make sure that you set up your equation and show work. All right, next one says so given that triangle QRS with Q is 90 degrees, RS is 15, and QS is 10, calculate the measures of the unknown angles and the unknown side length of the triangle. Round your measures to the nearest degree and whole number. Okay, so let's take a look at that one. I'm going to redraw it. Since this is Q, R, S, 15, 10, and then we want to know, I'm going to call this unknown R, I'll call this one S, and this one I'll just call it X. So to find the missing side, you can either use trig or Pythagorean theorem. On this one, I would probably use the Pythagorean theorem. So a squared plus b squared equals c squared. Remember, C has to be the hypotenuse. Always, C is the hypotenuse. And so that would be, my hypotenuse is 15. A and B can switch, so I'm going to say x squared plus 10 squared equals 15 squared. X squared plus 10 squared is 100. 15 squared is 225. To get x by itself, I'll subtract 100 from each side. x squared equals 125. X equals, I'm going to square root both sides. Now, since it says to the nearest whole number, you don't need to simplify this as it's 5 root 5, but on the calculator, we can just do square root of 125. Again, remember on my calculators, you'd have to hit 125 and then square root. That's 11.18. 11.18 rounds to the nearest whole number of 11. All right, next, I'm not going to use that value because if I make an error here, then when I try to find my angles, I will have another error. So instead, I'm going to use only the 10 and the 15. If I'm looking for angle S first, I'm going to be using hypotenuse. Remember, it's SOHCAHTOA. So I can't use tangent because I'm going to need to use my hypotenuse. I'm either going to use sine or cosine, and it depends. If I want to find angle R first, I would use the other one. I'm going to find angle S, so I have to decide if I'm at S, is this the adjacent or the opposite? This is my adjacent. And so I'll use cosine because I have adjacent and hypotenuse. So cosine S degrees equals adjacent over hypotenuse. Again, I'm going to discourage you from using the calculator for these problems. You can use the calculator to do this part, 10 over 15. So 10 divided by 15 is 0.6667, and that's cosine S. Now, the reason that I'm discouraging you from using your calculator is because some of you don't know when to use cosine and when to use second cosine, which is cosine inverse. So this time we're looking for the degree. Think about what you have on your trig table. Right? On your trig table, we don't know the degree, right? The degrees are unknown. So we have to find under cosine, we have to find this value, 0.6667, or the closest thing to it. So 0.6667 in cosine is closest to 0.6691, which means that my angle is 48 degrees. So we know that S is equal to 48 degrees. You can repeat this using sine R equals 10 over 15, which would give me sine 0.66 of R equals 0.6667. So then under sine, I would look for 0.6667, and it is right here at 42 degrees. Or you could use the other method where you take 180 minus 90 degrees for this angle, which is 90, minus 48, and that leaves you with 42 degrees. So angle R is 42 degrees, right? These have to add to 180. Either method that you like. Well, number 16, find the sine, cosine, and tangent ratios of the acute angles given the following triangle. So you need to find for both A and B. So we have this triangle. Here's A and here's B. My hypotenuse is 10, my long leg is 8, and my shorter leg is 6. So we're going to set up the sine, cosine, and tangent ratios, again using SOHCAHTOA. We want all three for both angles. So we want sine A, we want sine B, we do want sine B. And we want cosine A, and we want cosine B, and we want tangent A, and we want tangent B. All right, so sine A, if I'm standing here at A, my hypotenuse won't change no matter where I'm at. My hypotenuse is across from the right angle. So I'm going to have a 10 in the denominator. Sine is opposite to hypotenuse. Opposite of A is across from A or not touching A. Right, this side is touching A, so it would be 8 over 10. Now, if you have 8 over 10, that will reduce. So you do need to reduce it. I'm going to reduce them all at the end, though. I'm going to stick with my angle A. So cosine A would be still over 10. It'd be adjacent, which would be this side. Touching A is 6. And then finally, tangent A. Tangent A would be opposite over adjacent, which is, look right here, 8 and 6. It'd be 8 over 6. All right, if I switch over to B, if I'm standing here at B, right, then my sine and my cosine ratios actually just flip. Because now opposite would be 6 over the hypotenuse, and adjacent would be 8 over the hypotenuse. And then for my tangent ratio, it just is a reciprocal, right? Opposite over adjacent now is, instead of 8 over 6, it's 6 over 8. All right, I'm going to go ahead and reduce each of these. So sine A equals divide by 2, that's 4 over 5. Sine B, divide by 2, it's 3 over 5. Cosine A, divide everything by 2, 3 over 5. Cosine B, divide by 2, that's 4 over 5. Tangent A, divide by 2, that's 4 over 3. And tangent B, divide the top and bottom by 2, that's 3 over 4. And those are all 6 of the ratios. All right, and last one, number 17, says Tim draws a rectangle with a length of 3x squared plus 1 units and a width of x plus 2 units. Find the area and perimeter. So I'm going to redraw Tim's rectangle. This is 3x squared plus 1, and this is x plus 2. All right, so to find the perimeter, perimeter is 2 lengths plus 2 widths, or add all sides. That is the definition of the perimeter. All right, so to find the perimeter, I'm going to add all 4 sides. Don't forget we have to add all 4 sides. So I'm going to have 3x squared plus 1 plus, I'm just going to do this vertically, 3x squared plus 1, that's 2. That's, remember when you're adding, if you have 3 of something and 3 more, you don't have 6 of something new. You have 6 of this, 6 x squareds, and then plus 2. All right, plus to that, I'll add x plus 2 and x plus 2. And so that gives me 4. And again, this is not x squared. Why is x plus x squared? It is not. 1 apple plus 1 apple is 2 apples. All right, so 1x plus 1x is 2x. And now I'll add these together. That's 6x squared plus 2x plus, I can combine like terms, that's 6. All right, area. To find the area is equal to length times width. So to multiply the length times the width, 3x squared plus 1 times x plus 2, I'm going to use a little generic rectangle. 3x squared plus 1 times x plus 2. So now when you're multiplying, remember we have x squared, we have 3x squared times x. This is going to give me 3x to the 1, 2, 3, 4. 3x squared times x, right? X times x and then times x. This is going to be 3x to the 3rd. And then I have x times 1. All I can do is stick those together with multiplication. 2 times 3x squared, 2 times 3x squared is 6x squared. And then 2 times 1 is 2. If there are any like terms, they'll line up, but these are not alike. Remember, they have to have the same variables, which these all do, but they don't have the same exponents. None of them do. And so my area is 3x cubed plus 6x squared plus 1x plus 2. All right, guys, that's the entire review. I hope you have a good weekend, and I will see you on Monday.